In this video, I'm going to show you how to find the area of regular polygons, just any regular polygons, not necessarily hexagons, okay? What I'm going to show you will work for hexagons. However, it's not really needed because hexagons are special and there's kind of a shortcut that makes hexagons a little bit easier to work with, okay? In this case, we're going to look at a pentagon. It's a regular pentagon. It has equal side lengths. It has equal angle measures, okay? You need to be very careful. Pentagons do not break up into equilateral triangles, okay? You are going to break it up the same way, okay? You're going to do this kind of spokes pattern out of the center like this, okay? However, I have 5 angles here that make a complete circle, okay? If each of those 5 angles is 60 degrees, 5 times 60 is 300, okay? I can't have a circle that's got 300 degrees, okay? Remember I told you in the hexagon video, being able to find the angle measures of the regular polygons is super important, okay? I hope you remember, pentagons do not have 120 degree angles, okay? If you've forgotten, you can find the angle sum. Remember, you can take the number of sides minus 2 times 180, okay? It tells you that the interior angle sum of a pentagon is 540 degrees, okay? If you divide that by 5, each angle of a pentagon is going to be 108 degrees, okay? So this angle is 108, this angle is 108, all the way around, okay? Notice that 108 degree angle there is getting bisected, okay? When it gets bisected, you're not going to get 60, you're going to get a 54 degree angle there and a 54 degree angle there, okay? And it's not 54, 54, 54. You've got 5 angles here that add up to 360. 360 divided by 5 is 72, okay? That's what's going to make the angle measures of that triangle add up to be 180 degrees. So you got to be careful. Pentagons do not break up in equilateral triangles. Don't try to use 30, 60, 90 patterns for these problems, okay? I'm not going to use the 72. By the way, if you've kind of forgotten, you can also use exterior angles. Remember, exterior angles add up to 360 degrees. So 360 divided by 5 is it's 72. And so if you had a 72 out here, put a 72 over here, 72 plus 108 is equal to 180. So it might be a little bit easier actually to use exterior angles. All right, so here's the big deal. If I can find the area of one of these triangles, there are just 5 congruent triangles here. I can just multiply that by 5 and I've got the area of the whole pentagon, all right? So I'm going to focus on just one triangle here. So let's look at one of these triangles, okay? It's got 54 degree angles, okay? I'm not even going to worry about that angle at the top. We know that this side length is 10, okay? Remember that the area of a triangle is half the base times the height, okay? I already know the base is 10. So all I'm really trying to do is find that height right there, okay? The height, and this applies to the hexagon problems as well, although I didn't actually put it in the video. The height of one of these triangles goes from the midpoint of a side to the center. It has a special name. It is called the apothem. Apothem. A-P-O-T-H-E-M. Okay? H there is the apothem. By the way, that word is misspelled a ton, not misspelled, sorry, it's mispronounced a ton in geometry courses. It's apothem. That's how it's pronounced if you look it up in the dictionary. Anyway, I need to find that length there, okay? It's not a 30, 60, 90 triangle, okay? Well, guess what? I didn't memorize relationships of sides for right triangles with 54 degree angles, okay? This is going to require the calculator. This is one of the reasons we did all the work with trig back in chapter 9. Okay, we're going to need trigonometry to figure out what that height is, since this is not a triangle that we've memorized patterns for. Okay, make sure your calculator is in degree mode if you're going to do this. And remember, we've got our Sohcahtoa rules. Sohcahtoa. Okay, I'm going to take a look at just this half triangle right here. If this whole length is 10, this length would be 5. We're looking for this height here. I've got a 54 degree angle. Remember, when you work with trig, you're going to have an angle, and you're going to have 2 sides of a right triangle. One of those will usually be a variable, and that's what we have here. Okay? So notice I have the opposite side, and I have the adjacent side. Opposite and adjacent is a tangent relationship. okay? So I'm going to write the trig equation here. The tangent of 54 is equal to the opposite side over the hypotenuse. That's h over 5. Okay? If I want to solve for h here, which is what I'm trying to accomplish, I can multiply both sides by 5. So I really just need to find 5 times the tangent of 54, and that's going to give me my height. So I'll put that in my calculator, 5 times the tangent of 54, and I end up with about 6.882. Okay? And I would go to probably at least 3 decimal places. 6.882 is approximately my apothem length. And in fact, if you can keep it in your calculator, that's even better. All right? So the area of one of these triangles here, that height of that triangle is 6.882. It's half the base, base is 10, times the height, which is about 6.882. Okay? So the area of one triangle, multiply that by the base, and I'm going to take half of that. Okay, the area of one triangle is approximately 34.4095. Okay, and that's one of the 5 triangles. I use that whole base there. So I can take that and I can multiply by 5, and that'll tell me the area of the whole thing. So find the area of one triangle. There are 5 congruent triangles there, and we can find out that the area of this whole thing is approximately, and again, you'll have to do some rounding here, probably at least 2 decimal places, 172.05 square units would be my final area. Okay, so pretty challenging problem. That's how you can find the area of a pentagon. All right. In a future video, I'm going to show you a different formula. The shortcut formula can be used. This approach will always work though. Use trig and angle measures, find the area of one of the triangles, multiply by the number of triangles, you've got the area of your regular polygon.